So today we're going to do probability of independent and dependent events. As always, please complete the do now, watch this video of examples, complete the Google form on independent and dependent events, and then complete the reflection. Today's reflection is important because I am posting your progress reports, so I need to know if you made up any assignments so I can adjust your grade. Some people are still missing IXL from last week. So dependent events have an impact on each other. So if I have a group of marbles and I pick a marble and then I do not replace it, the probability of the first event has an impact on the probability of the second event. They are called dependent. The outcome of the first affects the second. If it's independent, the outcome of the first does not affect the second event. So this would be like flipping a coin and rolling a dice. The outcome of the coin has no effect on the dice. Okay, you'll see a few of these examples. So this is an independent event. The outcome of the spinner has no effect on the coin. So you are spinning the spinner and you flip the coin. We want to know the probability you land on an odd number and flip tails. So we take the probability of an odd first, and 1, 3, and 5 are odd, so that is 3/5. So that's the probability of the odd. And then we need the probability of tails. So we look at the coin and the probability of tails is 1/2. We multiply them together and the probability of landing on odds and flipping tails is 3/10. The outcome of the spinner has no effect on the coin. So you probably remembered the spinner and the coin from last week from compound probability. This is new. This is dependent events without replacement. So watch carefully. You randomly choose one of the chips. Without replacing the first chip, you choose a second chip. What is the probability the first chip will be yellow and the second will be red? So we need a yellow first and then a red. Let's look at the probability of the yellow. The probability of the yellow is 1 out of 6. Okay, now we assume we got the yellow. It no longer exists. We are not replacing it. So it's no longer there. Now we need the probability of the red. Well, now there's 2 red out of only 5. So notice, because you didn't replace it, the denominator decreased. And now we multiply. And we would get 2/30, which we can reduce to 1/15. Okay? Without replacing, the denominator goes down by 1 each time. So let's look at this again. Without replacing. So you randomly choose one of the chips. Without replacing the first chip, you choose a second chip. What is the probability? The first will be even and the second will be odd. So we always assume it's a success the first time. So let's look even. We have 3 out of 6, right? And do not reduce it, leave it as is because it's easier to change the denominator. Now we are going to assume we picked the even. You always assume you got what you wanted. Now the next pick has to be an odd. So that is 3 and there's only 5 left. So now we multiply together. 3 times 3 is 9. 6 times 5 is 30. And we can reduce because 3 goes into both. So this becomes 3/10. So the probability of the first is an even. There were 6 chips to start, so it's 3 out of 6. We assume we got the even, so it's eliminated. And now the probability of an odd is 3 out of 5. The denominator always decreases when you do not replace the chip. So the last example I want to do for today is a student randomly guesses the answer for each of the multiple choice questions. What is the probability of answering all 3 questions correctly? So in this case, they are all independent because the guess on the first question has nothing to do with the second. So if you look at the first question, I have a 1 in 5 chance of getting it correct because I have letter choices A through E. So there is 5 choices. I stand a 1 in 5 chance of getting it correct for question 1. Question 2, same thing. It's independent. I still stand a 1 in 5 chance of getting it correct. And question 3, I still have 5 choices, so I stand a 1 in 5 chance of getting it correct. And now it's independent. I multiply the probabilities together. So 1 times 1 is 1, times 1 is 1. 5 times 5 is 25, times 5 is 125. So I stand a 1 in 125 chance of guessing all 3 of these questions on a quiz or a test correctly. Okay? Independent, the result for one has nothing to do with the other. So please try your best. If you need help, join Zoom at 10 a.m. Use the link you received in your email. If you did not get it, please email me. Remember, independent, the most common independent is a spinner, a coin. Dependent events you'll always see as tiles, marbles, and you will see for dependent, it will say without replacement. Without replacement means the denominator decreases. You are not replacing it. If you have any other questions, you can email me. Have a good day.